Our next lesson is called Graphing in Slope-Intercept Form. You will get a bit of review of graphing in slope-intercept form linear equations from last year. Also, you will learn how your graphing calculator can aid you in creating these graphs. We'll start with part 1. Part 1 says, in order to use the graphing calculator for linear functions, the equation must be in slope-intercept form, y equals mx plus b, where m is the slope of the linear function and b is the y-intercept. We will do 2 examples together and then you will have some time to practice the remaining. For the examples, we're going to put the following equations in slope-intercept form. In other words, we need to solve for y. So if I look at part A, I have y minus 3x equals 1. If I want y to be alone, I need to get rid of the subtraction of 3x by doing the opposite, which is adding 3x. Whatever I do to one side, I must do to the other. So I get y equals 3x plus 1. Now I could write 1 plus 3x, but I'm trying to keep it in y equals mx plus b form, so it's easy for me to identify the slope and the y-intercept. So for example, the slope here would be 3, the y-intercept would be 1. Okay, letter B, y plus 5 equals 3x. I want to get rid of the 5 by subtracting 5 on each side. So y equals 3x minus 5. So what I'd like you to do now is pause the video and try C through F on your own. When you're ready to check your answers, you can resume your video. Okay, letter C, 6x plus 2y equals 4. I need to move the x's because my goal is to get y alone. So I have 2y equals negative 6x plus 4. But this still leaves me with 2y. So I have to divide every single piece. So all 3 pieces you see there need to be divided by 2, which gives me y equals negative 3x plus 2. Part D, x plus y equals 25. I need to move the x by subtracting x from both sides. So y equals negative x plus 25. In part E, y plus 5 equals 1/2 x. We want to move the 5 by subtracting it from both sides. So we get y equals 1/2 x minus 5. And then lastly, we have 0.4x minus 0.5y equals 10. I will get rid of the 0.4x by subtracting it. So negative 0.5y equals negative 0.4x plus 10. I will then need to divide everything I see by negative 0.5 for an equation of y equals 0.8x plus 20. Now, knowing what you know about slope and rise over run, it would probably be helpful to take this in certain situations and make 0.8 a fraction into 4/5 x plus 20. And remember, your calculator will do that under the math key, converting things from fractions to decimals. Now we're going to go into some basic graphing. I will show you what the notes say, and then I will show you what things look like on the graphing calculator. So first of all, when you enter equations on your graphing calculator, you need to go to the y equals area, which is a button on the top right under your screen. Those are all your graphing buttons. When you go to that y equals screen, you want to make sure that your plots at the top are turned off. You can see a picture of that over here on the side. You don't want any of those to be highlighted. So if they're darkened, that means they're on and they're highlighted. You would just move your keypad arrows over to one of the plots, hit enter, and it will turn it off. Second thing, when the equal sign is highlighted, the graph will be displayed. So if you look at this right here, and you look at my example, right now y1 would show up on the graph, but y2 would not because y1's equal sign is shaded in. Now some typing options here. If you look at this section right here, y1 is the same equation for all the y1s, but showing you different ways you can type something. So first of all, if you had a slope of 1/2, you could make it 0.5. So that's the example they're showing you here. You can use 0.5. You could also use negative 1/2 x using the fraction key, which I will show you in a minute. And if you're going to use the division symbol, make sure that you put parentheses around it. Okay, underneath that, you're going to see that there's a symbol to the far left of the equation that indicates the style of graph you will see. Now, this diagram down here is of the older version of the calculator. So some of you with the older version might decide you want to use this. You would just use your arrow keypad to go all the way over to this section to the left. And as you hit enter, it will change the type of line that you have. On the newer calculators, most of them already are separated by color, so that's not something you would have to do. However, if you wanted to change the color, you could. Now looking at your graphing calculator, let me point out some of the things we just discussed under number 1. The y equals button you can see is in the top left corner. Okay, I have already entered the equations from that in the screen here. Just want to remind you that your keypad moves you around up and down, and I will go down to y4 just to show you again how to enter a fraction. Alpha y equals is the button you want to hit so that now you can pick fraction, which will turn that into a fraction. Okay, when we're discussing the area to the left, you see I can go over with the arrow and highlight that and change the color if I'd like. Those of you with the older calculator can hit enter and change the type of line. Up here on the top, you can see the plots. Mine are all turned off because they're blue. On my screen, again, yours will be darkened. If I were to have one on, you can see what it would look like. Mine turns red, and I would not be allowed to graph. So you want to make sure that your plots are always off. Now moving on to section 2, the viewing window. Choose the viewing window. We have talked about this before. I would like you to be choosing zoom, which is a key underneath your screen, one of the graphing buttons, and I want you to choose choice 6, which is standard. This will take you to your standard window that you see over here, going from -10 to 10 on the x-axis and the y-axis, with an x scale of 1 and a y scale of 1. Then from there, you can manipulate your window, you can zoom in or zoom out. Looking at what number 2 looks like on the graphing calculator, if I wanted to graph these, now remember they're all the same line, because I showed you every single way you could enter it. I want to hit the zoom key and then pick choice 6 by either using my keypad to go down to that or just typing 6. And you will see that your graph will come up in the standard window. If we actually want to look at the window settings, you hit the window key and you can see the -10 to 10, etc. there. You're allowed to change your X min and max. You can also change your scale at any time if you have a problem you're working on that you need to see more of the picture. But this is a good starting point. Okay, now for number 3. Anytime you get away from the picture of the graph, you can always hit the graph key again to see your graphs. So again, when you originally graph it, I want you to hit zoom 6 standard, but then as you're moving around doing other things on your calculator and you just want to refer back to your graph, you can use the graph button. Number 4 says you can find the roots of the equation if you'd like to. There's a calculate function. I will be talking more to you about this as we get closer to needing things like roots and intersections. Then if you look at number 5, if you need to see the values relating to the graph, you can go to the table. You can control what you see in the table by going to table set, which is second window. So you're going to notice in these notes, there are directions in the left side, and then there are pictures of what you should be seeing on the right side. So if I'm looking at this graphing calculator, again, I can hit graph to go back to a picture of my graph. But if you'd like to see the table, you are going to hit second graph, and that will take you to what the table values are. This is where you will go to write down your work. So now when you are graphing, you will graph it, look at the table, and give me a snapshot of the table as your work. Now this table you can manipulate to show you what you want. You do that by hitting second window. This is your table set screen. So you can decide where you want to start. So let's say I want to start at -5. You can decide what you want the table to change by. Right now I'm going by 1s, but you could make this 0.5, 0.2, by 2s. You can change that at any point. So that way, when you go back and look at the table by hitting second graph, you can see my table starting at -5. So you can manipulate what you see. Okay, now I would like you to practice. You're going to draw the graph of the equation below and show your work. Please use your graphing calculator to do this. So you might have to change the equation into the proper form and then practice going to your graphing calculator, graphing this, and getting a table of values as your work. When you are ready, you can resume the video to check your answer. Okay, so first you would have had to move 5 because we want it in y equals mx plus b form. So it's y equals 3x minus 5. Then, when I type that into my graphing calculator, graph it, and take a look at the table, I'm going to give a snapshot of the table as my work. So -1, -8, 0, -5, 1, -2, 2, 1, 3, 4. I also had 4 and 7. 5 points should be plenty. I did 6. So -1, -8, I'm going to plot 0, -5, 1, -2, 2, 1, 3, 4, and then 4, 7. You can see it's following in the pattern of a line. Going to connect it, put arrows on the ends, and then make sure you label it with the original equation, y plus 5 equals 3x. It is going to be difficult to read these points off of your graphing calculator, so you are going to need to rely on that table to help you identify the specific points, which will make it easier for you to graph. Now we will move on to part 3, which is slope point form of a linear equation. So this is different than y equals mx plus b form. The point slope form of the equation of a straight line is this formula that you see here. The y always stays. This x always stays. y1, m, and x1 will all be numbers. And it's important to note in the formula that we have subtraction used. So that's going to help us later when we're trying to figure out the points. So using this formula, here's what we know. We get 1 point. That point is going to come from the x1 and the y1. Okay, and again, you got to watch out for the signs. So watch the signs. And the second thing we get from this formula is the slope. So to graph the line, we plot the given point, and then we use the slope to find more solutions. Remember, that's rise over run. So we will do an example here. We're going to draw the graph of the equation below and show our work. So we're using the formula that we've talked about up top. So when I see y minus 2, the y and the minus are part of the formula. So that means my y1 is 2. So x1, y1. I know my y value is a 2. When I look at the formula, it's supposed to be x minus a number, and I see x plus a number. So that means this must have come from x minus a -5. Double negatives would then turn into x plus 5. So that means my x value is a -5. So I'm going to plot -5, 2. Now that I know that point, I can use my slope to get more points in order to create my line. So my slope is the number that's in front of the set of parentheses. In our case, is it a 3? We want to write it as a fraction so that we can use rise over run. On top, if it's a positive 3, we should be going up. On the bottom, if it's a positive 1, we should be going to the right. So I will go up 3 to the right 1. And if I run out of space, I can go down 3 to the left 1. Connect those arrows and label it with the original equation. Y minus 2 equals 3 times x plus 5. Now at this time, I'd like you to practice one on your own. When you're ready to check your answers, you can resume the video. Y plus 2 equals 1/3 times x minus 1. We want to come up with our point. So if I look at my y plus 2, remember there's supposed to be a subtraction in that formula, so it really must have been y minus a -2. So my y value is -2. And here, x minus 1, the x and the minus are part of the formula, so my x value is a 1. The slope is located in front of the set of parentheses, so that's 1/3. Using rise over run, the number on top is a positive 1, so I'd go up 1 and to the right 3. So I'll start by plotting 1, -2. Then I will follow my slope, up 1 to the right 3, up 1 to the right 3. Again, if I run out of space, I can go down 1 and to the left 3, down 1 and to the left 3. Connect arrows and then label it with the original equation. And that concludes your lesson on graphing in slope-intercept form.